Hello everyone, and welcome to another video in my channel. In this video, I'll be solving for x given that the x root of x squared is equal to the fourth root of 4. I shall be presenting two methods. In the first one, I'll be applying the properties of indices. First, we know that if we have a problem like this, a and here is b, and let's say here is c, it can be written as a raised to power c over b. So I'm going to convert these terms in both the left and right hand side of the equation, applying this. That becomes, here will now be x raised to power 2 over x is equal to, here becomes 4 raised to power 1 over 4. Now let me divide the powers by 2 so as to remove this 2 here. The purpose is to ensure that the numerator here of the power is 1. That becomes x raised to power 2 over x times 1 over 2 is equal to 4 raised to power 1 over 4 times 1 over 2. These two will cancel these two, giving us x raised to power 1 over x equals to, now these 4 will be multiplied by these 2, 4 raised to power 1 over 8. Now what I need to do is to manipulate this part of the equation, the power particularly, such that the denominator will become the same thing or equal to the base here. For me to do that, I need to multiply and divide the power by 2. Since 2 divided by 2 is 1. So I have here 4 brackets 2 times raised to power 1 over 16. Good. The property of indices I applied here is this. If I have a raised to power n multiplying raised to power m is the same thing as a raised to power nm, or the same thing as a raised to power m bracket n. More like the powers. This power here is moved inside and this is used to multiply this. So I have x raised to power 1 over x is equal to 16, because 4 to the power 2 is 16 raised to power 1 over 16. If I equate the bases, x equals to 16. If I equate the powers, 1 over x equals to 1 over 16, I'll still get x equals to 16. So I have x equals to 16 here as a solution. Now in the second method, I will apply the properties of logarithm. So I have the question as x raised to power 1 over x is equal to 4 raised to power 1 over 8. The first thing I will do is to ln both sides. So that is, I'm going to take the natural logarithm of both sides. Here is ln x 1 over x is equal to ln 4 1 over 8. The purpose is to bring down this power according to this property of logarithm. If I have ln p raised to power n, it is equal to n ln p. This power will come down, but I will choose to leave this power the way it is. So I have 1 over x ln x is equal to ln 4 raised to power 1 over 8. There's another way I can rewrite 1 over x. If I have e raised to power ln x, it is the same thing as x. So if I have e raised to power ln 1 over x, is the same thing as 1 over x. Also, it is equal to e raised to power minus ln x. So I will write this in place of this. That becomes e raised to power minus ln x times ln x is equal to ln 4 raised to power 1 over 8. Now let me write this one first, since this is multiplication and multiplication is a commutative operation. So I have ln x times e raised to power minus ln x is equal to, I can choose now to bring down this one or leave it the way it is. That is ln 4 raised to power 1 over 8. Let us multiply both sides by minus. I want the power here to be the same thing as this base here. So I have minus ln x multiplying both sides by minus 1 rather, times e to power minus ln x equals to minus ln 4 raised to power 1 over 8. Or it's the same thing as minus 1 over 8 times ln 4, which is our minus ln x times e to power minus ln x. Good. At this point, I need to apply the Lambert W function method, and I'm going to do it up here. So what do we know about this Lambert W function method? If I have x times e raised to power x, and I take the w of both sides, it is equal to a constant first. Then here will give me x equals to w of constant. So our problem, which is this, is now in this form. Remember, we have minus ln x times e to power minus ln x equals to minus 1 over 8 times ln 4. So it's exactly in this form. I can now successfully take the w of both sides. Here will now give me minus ln x equals to w of minus 1 over 8 ln 4. The value of this is minus 0.17329, that is minus ln x. Now I can rewrite this one as ln x raised to power minus 1 equals to, now this will give us two values. One of them is minus 2.77256, and the other one is minus 0.214816. If I take the e of both sides, x to power minus 1 will now give me e of minus 2.77256, or e to power minus 0.214816. 1 over x equals to, here will give me 0.0625 or 0.8067. So 1 over x, or rather x equals to 1 over 0.0625 or 1 over 0.8067. X equals to 16 here, or x equals to 1.25 here. So we have two values for x. If we now put the value of 16 or 1.25 in the original equation, we will get a balanced equation. Thanks for watching. If you are new to this channel, I would like you to subscribe to this channel. And as you do so, turn on the notification bell so that you will be among the first that will be notified each time I upload a video. I would also like you to leave a comment in the comment section. Like this video if you find it very, very interesting, and share this video to your loved ones. Bye for now, and see you in another video.